What's up, fellow polymaths? In this video of the Java Fundamentals tutorial, we'll be going over operators. Operators in Java, and pretty much just about every programming language, are used to perform operators on variables and values. You can think of operators in Java as operators that you have hopefully seen in your math class. There are different types of operators. There's arithmetic operators, assignment operators, bitwise operators, comparison or relational operators, logical operators, shift operators, ternary operators, and unary operators. Arithmetic operators are used to perform math operations. And here we see some common math operations that are used for the arithmetic operators. We have the addition, subtraction, multiplication, division, modulus, increment, and decrement. So you probably are aware of what addition, subtraction, multiplication, and division are. Modulus, if you're not aware, is getting the remainder of a result. So let's say you do 5 divided by 3, for example. The remainder is going to be 2. So the result that you get from doing a 5 modulus 3 is going to be 2. Increment is when you increase the value by 1, and decrement is when you decrease the value by 1. So for incrementing and decrementing, depending on where you put the operators, they might have some different results. So let's post some examples for the arithmetic operator. All right, so here we're in Eclipse, and I have two integers, a and b. So we have assigned a to equal 10 and b equal to 6. And I posted out some print line statements just to display the arithmetic operators. So we're going to run this code right now, and I'll explain the results. All right, so here we have the result. So as we see here, we have the values output, 9 of them. A plus b, pretty much self-explanatory, we get 16. A minus b, we get 4. A times b is 60, 10 times 6. And here I casted a double to both a and b, because if I did not, then the result would be 1, because 10 divided by 6 as an integer results in 1, because the integer is cut off the decimal point. So that's why I casted a double. A modulus b, remember modulus is just the remainder, so the 10 divided by 6 results in a remainder of 4. So this is incrementing a, the left-hand side of the variable a, and our result is 11. We do the same, except this time we're decrementing using the left-hand side, and our result is 10. And we're also decrementing here on line 17 of the code, but this time on the right-hand side. And notice that the value says 10 right here. So it's the same value as the decrement before, but you think that it'd be different. It'd decrease. So now on line 18, I put this, I output the variable, and we see here that it changed to 9. So when you put the incrementing or decrementing operator on the right-hand side of the variable, it doesn't take effect right away. It'll take effect after a variable is called afterwards. So for assignment operators, we've already played around with this in the previous tutorials. Assignment operators just assign values to variables. So for example, if we have a variable named power level that's an integer, we can assign that to equal 9,000. Math assignment operators can be used as a shortcut for inputting the assignment operator statement. And here we have some examples of math and assignment operators. All right, so here we're going to test out the assignment operators and some math operators. I added in a variable c that's a double, and here we're just going to compare the assignment operators and the math operators. So the bottom 5 here on line 17 and 21 are like a shortcut for the traditional math operators. So let's run the code. So here our first result is 16, because 10 plus 6 equals 16. The next result is 4, because 10 minus 6 is 4. And then we have 10 times 6 is 60, and so on. So we're familiar with the first 5. So the next is the shortcut for the math operator. So a plus equal to b is the same as a plus b, or is the same as a is equal to a plus b. In this case, it's 16. A minus equals b is the same as a is equal to a minus b. So now, because even though we're getting 10 right here, so you might be wondering, shouldn't we be getting 4? Well, because a originally was the assignment, so basically when we called this on line 17, it assigned a as a plus b. So now a's value is 16. So when we get to line 18, it's saying A's value is currently 16. So when it's subtracted by B, which is 6, now it gets turned into 10, which is the result that we get right here. So now A's value is back to 10. So now we do A times equal to B, which is the same as A is equal to A times B, and our value is 60. So now on line 20, when we do a division, A divided by equals to B, again, this is A is equal to A divided by B, our result is 10. And then finally, our A modulus equal to B is the same as A is equal to A modulus B. So basically the modulus is the remainder. So this is, in this case, would be 10 divided by 6, and our remainder for that is 4. So for comparison and relational operators, these are used to compare variables and values. The first operator is equal to. When you think of this double equal sign, think of this as equal to when you're comparing variables. The regular equal sign with just one equal sign, that's an assignment. But these two equal signs means equal to. So when you're comparing values, you say A is equal to or double equal to B, which is the same as equal to. The exclamation and equal sign is not equal to. So basically you're checking if, for example, A is not equal to B. And of course, the third line is the greater than, and then you have the less than, and greater than equal to, and then less than and equal to. So here we're back in the code, and we're going to test out those comparison operators. So I made some code for comparing the two variables that we have. So let's run this code right now. All right, so here we have our Boolean values as the result for these logical operators, or rather comparison operators. So the first line, A is equal to B. So where the compiler is checking is 10 is equal to 6. Our result for that is false. Of course, 10 is not equal to 6. So the next line is A not equal to B. So in this case, it's 10 not equal to 6. In that case, that's true. 10 is not equal to 6. So then the next line is 10 greater than 6. And that's also true as well. And is 10 less than 6? Of course, that's false. And then checking if 10 is greater than or equal to 6, and that's true. And if 10 is less than or equal to 6, and of course that's false. So it's pretty straightforward, especially if you dealt with comparison and relational operators. Logical operators are used to retrieve a Boolean result, so basically true or false. We have three main logical operators. There's the logical AND, which is 2 ampersands. This returns true if both statements are true, or else it returns false. Logical OR, which is 2 pipe symbols, and this returns true if at least one of the statements is true. But if both are not true, then it will return false. And then there's a logical NOT operator, which is an exclamation. So this is the opposite result of the Boolean. So this returns false if it's true, and it returns true if it's false. So let's test these logical operators out. So here I've made some code to test out the logical operators. So now we're just going to run this code. All right, so here the result. The first result we have is checking, and remember A is equal to 10. So first result is checking if A is greater than 5 and A is less than 15. We know our value for A is 10. Is A greater than 5? Is 10 greater than 5? Yes, that's true. And is A less than 15? That's also true. So the result for that is going to be true. So the second line, if A is greater than 5 or A is less than 9. So is A greater than 5? Or in this case, yeah, is 10 greater than 5? That is true. Or is A less than 9? So in this case, 10 less than 9. 10 is not less than 9, so that's false. But because this condition evaluated as true, this whole result is going to be marked as true. Because remember, with an OR, only one condition has to be true. Even if you have 100 conditions and 99 of those are false, as long as one of those conditions is true in an OR condition, then that whole result is going to be true. So the final line on line 12, we're checking is not, remember exclamation means opposite, A is greater than 5 and A is less than 15. So we know A is greater than 5, and we know that A is less than 15. So this part is true. But remember, we have that exclamation, which means the opposite. So because this condition is true that I have highlighted, and we have this opposite right here outside of parentheses, this whole condition gets evaluated as false. And we see that right here. Bitwise operators are used for integer variables such as byte, short, character, int, and long. Bitwise operators are mainly used in lower level programming, which is programming that's very close to the hardware level. So you can think about lower level programming like device drivers, protocols, etc. Basically things that allow the operating system to run. The bitwise ampersand operator checks all conditions, whether the first condition is false, whereas logical operators, the double ampersand operator doesn't check other conditions if the first condition is false. Bitwise operators are mainly used with binary numbers. For the order of operations, it's similar to the math order of operations. So if you remember from math class, or if you're aware of it, there's the PEMDAS. So the order of operations determines which expressions are evaluated first. Here are the exact order of priority for the order of operations, with the top being the most priority, the bottom being the least priority. These you don't have to remember offhand. Just know that the increment and decrement is the highest priority, and then followed by the multiplication and division, and then the addition and subtraction. Those are the ones that you're going to see most frequently. Of course, the logical and the logical OR are you'll also see as well, but those are the lower priority in terms of order of operations. So here's an assignment for this topic. Number 1, given the statement system out print line not 5 is equal to 5, what will the statement evaluate to and why? Number 2, write a program that will output math operators for addition, subtraction, multiplication, division, and modulus. Number 3, solve the following. Integer x is equal to 10, integer y is equal to 20, and then system out print line not x is greater than y. If this video was any value to you, then please leave a comment, like, share, and subscribe. Thanks for watching, and I'll see you later.